Okay, this is the problem-solving part of the lecture. True or false? Is 7 congruent to 9 mod 2? That's a nice easy question. Well, so that's your A, that's your B, that's your N. So remember, does A minus B, can you divide that by N? So A minus B would be 7 minus 9, which is minus 2. Now can you divide minus 2 by N, which is 2? Can you divide minus 2 by 2? Yes, you can. So that's okay, that's true. Second one, true or false? So that's true. Now, is 3 conjugate to minus 5 mod 4? Is that true? Well, A minus B, so that would be 3 minus 5. So that's 3 plus 5, which is 8. And 4 does divide into 8, so that's okay. So 7 and 9 are conjugate mod 2, 3 minus 5 are, congruent mod 4. And let's try this one. Is this true or false? So 5 is not congruent to minus 13 mod 3. Right? Is that true or false? Okay, A minus B, so that'll be 5 minus 13. So that's 18. And 3 does divide into 18. So 5 and minus 13 are congruent, mod 3, but it says here they're not congruent, so that's false. Right? So that's false. That's true, that's true. Okay, that was question 3 in the text, chapter 4, in the exercises. Actually, there's a little bit of theory I didn't cover, so I'll just do it quickly now. This symbol here, Z to the suffix N, that's a set. It's a set of residue classes. Now if you have modulo N, you'll have, well I rubbed it out, but if you have, if your modulo is N, you'll have N residue classes. Okay? Now, and each residue class is, or a residue set, is a set, right? It's a set. So if you put all those N sets together in a set, so you have a set of sets of all possible residue classes, N of them, then that superset, that set of sets, if you like, you label as Z subscript N, like this. Okay? Now, if you're dealing with this set of sets, the members of that set are, each of them is a residue class. Okay? Now, theorem 8 was it? We proved that you can add residue classes, and you'll get this kind of thing. Now we're assuming that the modulus is the same throughout, so you get that kind of thing. So what if our class of residue classes is written this way? So N here would be 3. So what is that? Well, it's the set of sets, or the set of residue classes. So they would be, right? That's all there are. Okay. And so this is 3. That's the modulus. Okay. All right. Well, in that context, question, given this, we're dealing with Z3 or Z3, what is the following? 2 plus 2, and the modulus is 3. What is that? Using arithmetic of residue classes. What is that? Well, this is just a special case of that, right? So it's just that plus that. So that's 2 plus 2 n, and that's just 4 n. Now, sorry, 3. This should be a 3. Okay. Now think about what that means. What is a residue class? What is a residue class? It's the set of all integers that are congruent to 4 mod 3. Now think about that. Now there's another number. Now 4 is congruent to 1, right? Mod 3. 4 is congruent to 1 mod 3. Now all the elements in this set, they're all congruent to 4. But 4 is congruent to 1. And so all those elements are congruent to 1. So we can sort of simplify it down to that. So the answer to this is this. Okay? Now, by analogy, if our modulus is now 8, and we now have this set of sets, this set of residue classes, and since the modulus is 8, we'll have 8 of these. So Z3 will be something like this: 0, up to 7. Okay. All right. In that context, what is the following? What is 3? So that's a residue class, mod 8. It's the set of all integers that are conjugate to 3, mod 8. Right? And you add that to the following 5. So what will that be? Well, just use this rule. So that will be like 3 plus 5 mod 8. So that's 8 mod 8. But 8 is conjugate to 0 mod 8, right? So we can simplify it, just write it in this form. Okay? Now there's something similar with multiplying. And I'll finish off with squeeze it in here a bit. You're asked to solve the following question. It's an equation. So x squared is, you're told, is conjugate to 3 mod 11. What is x? Okay. Solve this equation, but it's a okay. So now it's mod 11. So you're restricted in the numbers that you're talking about, right? It's mod 11. So your range of integers that you can think about including 0 to 10. Right? So you could try x ranging from 0, 1, 2, up to 10. So try that. Okay, try, because we're talking about conjugate numbers, modulo 11. So there's no point going outside this range, because if it is, any number outside that range will be conjugate, mod 11, to one of these. Hope you follow that. Okay, so we only need to think about this range of integers. All right, we'll just try them one by one and see what happens. Well, if x is 0, that's not conjugate to to 3 mod 11. If it's 1, 1's not conjugate to 3. 2, that's 4, is not conjugate to 3 mod 11. I'll just go quickly now. If it's, what have I just, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do them one by one. No. 9, is that conjugate to 3 mod 11? No. 4, 16, is that conjugate to 3? No. 5, so that's 25 minus 3, that's 22, and 11 does divide 22, so that's okay. That's one solution. 5 is a solution. Let's try 6. So that's 36 minus 3, that's 33, and 11 does divide it. So 6 is also a solution. So 5 and 6 so far, right? 7, 49, 46, no. 8, 64, that's 63. 11 doesn't divide it, 63, so no. 9, 81, 78, doesn't, no. 100 minus 3, 97, no. Okay, 5 and 6. They're your two answers to that question. Alright, rather a long lecture, and quite a tough one. And as I said earlier, I wouldn't be at all surprised that this, because I haven't looked in detail at the forthcoming chapters, but I wouldn't be surprised that this lecture ends up being the toughest of them all. And it's not surprising because it's more devoted to theory of integers, which is theory of numbers, number theory, and number theory proofs can be quite difficult. But necessary, because we will use concepts, the division algorithm, relative prime, residue classes, conjugate numbers, and so forth. We will need all that theory for later chapters when we're talking about the theory of groups. And next chapter, chapter 5, we actually start on the real stuff, which is what this lecture set, this course is about, which is group theory. So lecture 5 will be simply groups. So we'll get on to the real stuff. So see you next lecture. Ciao.